Let's take a look at this problem. There are several parts for this question. The first one is to find all real zeros. Okay, what does that mean? Real zeros? That means you need to solve this equation. So set the function to 0 and the solution is called the zeros of this particular function. Okay, so therefore our job is to, okay, set this to 0. There are different ways to do that. First method is I will try to factor it if I can. So I'm going to factor out 1/9. I don't like the do I have to factor out 1/9? So let's take a look at this equation. Okay, this now becomes an equation. I can multiply both sides by 9 to eliminate the fraction because I dislike fraction. So when you multiply by 9, okay, think about you're multiplying each term by 9, okay? The first one, you're going to get x squared. The second term, you're going to 1/9 times 9 is 1, so you're left with x. The last term, you will get 2, right, which is equal to 0. And you can try to factor this guy. Actually, it can be factored. So it is actually x plus 2 times x minus 1 equals 0. You can double check, right? So you get 2x, you get negative 1x, they add to x. So therefore we are right. So with that, you know that x has to be negative 2. That's coming from right here, This, when you set this to 0, you get x equals negative 2. When you set the next one to 0, you get x equals 1, right? So therefore, these are the two solutions. So this is method number 1. Now, what about method number 2? Method number 2 is worth to mention because it's universal one. So this is the equation you have: x squared plus x minus 2. You identify your a, b, c, right? A is 1, b is 1, c is negative 2. So what is your a? A is the coefficient of this x squared term, b is the coefficient of the x term, and c is the constant term, which is negative 2 in this case. And then after that, you're going to say, hey, my solution using the quadratic formula is going to be 2 times a. Well, let's quickly write down the quadratic formula. B squared minus 4ac, okay? Now, if you apply this guy and you get 2 times a is going to be 1, negative b is your 1, plus or minus, b squared is 1, right? Minus 4 times a is 1, c is negative 2, negative 2. And then after you do the algebra, I'm running out of room, so I'm going to move it up, move it to the left. So negative 1 plus or minus square root of, if you do the algebra, 1 plus 8, which is 9, right? Divided by 2. And so, which is negative 1 plus or minus 3 over 2. When it is positive sign, you get negative 1 plus 3, which is 2. 2 over 2 is 1. When it is negative sign, negative 1 minus 3, which is negative 4, divided by 2, you get negative 2. That's what we have. We do have the same results. So that's how we find the zeros of that one. So we get 1 and negative 2, right? Okay. So determine the multiplicity. By the way, when we actually, I forgot to, we should just do that quickly when we look at the, when we factor. So we just have two roots, and when we factor, we got this one. Equals 0. And keep in mind, this power is 1, this power is 1. Therefore, this root is multiplicity is 1, and for 1, it's also multiplicity is also 1. So both are odd multiplicity, right? And the turning point, because this power 2, at most 2 minus 1, which is 1 turning point. And actually, we do have only 1 turning point in this case. And then you can use your graphing calculator to graph this one. So when I look at the graph, when I look at the graph, if you remember, we have two solutions. One is -2, the other one is 1, right? They're zeros, which means they're also x-intercept. Seems to me this x-intercept is like something like close to 3. We don't have this x-intercept. I can quickly rule this out. And for this one, this is -3, right? So we don't have this x-intercept. I also rule this out. And looks like this is correct because this is 1, right? And this is -2, right? And if you look at this one, this is -1. We don't have -1. We have 1. We don't have -1. So I'm going to rule this out as well. So you can see that zeros actually help you determine which graph is a good graph. By the way, you can use your graphing calculator or Desmos to verify the graph.